We were looking for a word feedback, and we said a feedback amplifier which is of interest to us. We have an amplifier which is say has a gain of AOL and it's called open loop gain, and it gives you a output of x0 when an input of xs is given or xi is given. And we also said that the part of x0 is returned to input and mixed with the signal to form the new xi. Okay. And if xf is in opposite phase to xs, that is the input signal is reduced by xf feedback signal, then xi will reduce, and if xi reduces, x0 will reduce, and if x0 reduces, the beta x0 which is a feedback signal also reduces. So xs minus xf will now increase and get a new xi, which when amplified by AOL will get a new x0 which is slightly larger, and this feedback will finally settle to 1 xf, xs and x0 values. So negative feedback essentially stabilizes the gain x0 by xs. This is the purpose of any feedback amplifier. I want to stabilize the gain, fixed gains. So if there is any noise or anything which is putting in this, and if I have a feedback ratio, then I will see that the gain stabilizes. Okay, that is the purpose of negative feedback. That is what we started with. We looked into a few things. We talked about A beta, we talked about this. We also looked into few properties of negative feedback. One of them we said about gain desensitivity, and we said the closed loop gain is A0 upon 1 plus A0 beta. Now please remember, if you are not working with Cedra Smith, many books this value will come x0 1 minus A0 beta. Do not get worried too much. What essentially they are saying, that the expression which I derived in getting this expression, I said xi is xs minus xf. So I already thought it is a negative feedback. What they are saying is they are actually giving it this plus, okay, and because of that they will get a 1 minus A beta values there, but essentially they are saying whenever xf is negative, put a minus sign correspondingly, okay. So beta will become minus and 1 plus A beta will again become as is there. So that is the trick of the trade. So if some books you are following in which they are writing 1 minus A beta, they are essentially using this plus with no sign of xf right now, but if it is a negative feedback it will subtract, and if it subtracts then that 1 plus A beta term will appear. Okay, so we said that if we have a feedback network, the closed loop gain with feedback means the change in such gain with reference to its initial gain will be proportional to 1 upon A0 beta times D0 by D0. That means any change in this, the closed loop gain will be much smaller by 1 upon A0 beta factor. That means it's desensitized the gain variation. That is what I was saying, stabilizing the gain. dA0 by A0 is the sensitivity of A0. If this sensitivity has to be reduced, and if I divide by some fixed factor, then the closed loop gain essentially shows less sensitivity compared to A0. That is the purpose of negative feedbacks. This is what we did last time. We also said by same logic we figured out that if there is a bandwidth and if there is a pole, midband upon something like this, and we finally said in a closed loop gain the bandwidth will also increase by 1 plus am beta times omega 0. That means the increase of bandwidth was essentially occurring because of what? Because the closed loop gain was lower than the open loop gain. AOL was higher than ACL. We reduced that by 1 upon A beta factor, and because of that by same factor the gain bandwidth also increased. Is that point clear, that the bandwidth increases by same ratios? Because why it should be of same? Because gain bandwidth for an amplifier will still remain constant unless transistors are changed. Is that clear? So since we are not changing anything else, so if the gain reduces by 1 upon 1 plus A beta, the bandwidth will proportionally increase by that much amount. This is the trick of increasing the bandwidth whenever you are looking for a larger bandwidth amplification. Where do you think you need larger bandwidth amplifiers? For example, of course these are not the amplifiers which we use there, but let us say we are using a mobile applications, mobile systems in which there are amplifiers. Of course they are at very high frequency. So is television signals, both video and audio. They are at 62 megahertz to 67 megahertz, 5 megahertz bandwidth. In case of GSM, it may be almost around a gigahertz bandwidth. So which means I want an amplifier which has a large bandwidth, but I may not have larger gains at larger bandwidths. This has to be, so in many cases I do not really need gain of 100, I need gain of 10, 15. So but I need larger bandwidths. So feedback is one way to improve the bandwidths, correspondingly reducing the open loop gains. Okay, this is universal and there is nothing to do with any of the kind of amplifier, everything. Feedback always reduces the gain. Negative feedback, I must clarify, negative feedback always reduces the gain. Why positive feedback, what will do? In fact it will, gain will start enhancing, or the output will start enhancing, because every time you give a feedback, input rises, so output rises. Part of reason output is further fed back as a larger feedback, so further output, so it is called growth functions. Okay. So now you can understand, if I have a system in which I have two kinds of feedbacks, one which is negative feedback, one is which is positive feedback, and I adjust their feedback such that the net feedback is 0. Okay. Such systems will be called oscillators. Okay. We will see what exactly are oscillators. Okay. So it must grow, but it should not grow randomly, so it should reduce some way, and that kind of system will follow a law which we will see using this theorem itself later, called Barkhausen's criteria. Okay. And we will see if the Barkhausen's criteria is not violated or is violated, oscillations damps down, okay, or infinite growths can start in either case. We also, I think last time showed you, there are 4 kinds of possible feedback amplifiers. The mixing is the word used at the input, that is the feedback signal mixes with input signal, and sampling is the word used, part of the output is fed back. What is the part coming from there? Okay, that part is essentially called sampling. I have a output, part of it is fed back, okay, so that is called sampling. So I can either have sampling done on currents or I can have sampling done on voltages. Same is, I can have mixing of voltages at the input source, or I can have current at the same node which may also mix with the current at the input. So essentially there are 4 possible amplifiers in which the input signals and feedback signals are of this kind, output is of this kind, and mixing can be series or shunt, depends on the way we define, we will show you that a little later. And these amplifiers are also therefore classified as voltage amplifiers, in which there is a series mixing, voltage is series mixed, okay, and the output is sampled also voltage wise, okay, and therefore it is called voltage output divided by voltage inputs. Such an amplifiers are voltage amplifiers. Please remember, all amplifiers can be called voltage amplifiers in the end. Why? Even if output is the current, if I put it across a load resistance, it will create a voltage at the output. So do not think that I am meant by current amplifier means only I am looking current, I am saying current will enhance and correspondingly IR drop may also enhance, but the gain essentially I will define only with the increase of whatever relationship I am taking. Okay. So one will be current amplifier, one will be if the input is voltage and output is current, then we say it is a transconductance. If the voltage input is current and output is voltage, we say it is a trans resistance amplifier. So we 4 amplifiers. I repeatedly saying that all amplifiers can be current amplifiers or voltage amplifiers per se, that is output to input ratio, you can choose anything you like, but the basic amplification is voltage to current or voltage to voltage or current to voltage is what we are saying by these 4 terms. We will see this now when we start having an example. we said there can be 4 possible mixing and sampling. Here is 2 kinds of mixing we showed. I think instead of this I can directly show you the better ones. I mean they are separated, now I mixed both of them. So you can see I have a voltage amplifier which has a voltage gain. So if it receives an input Vi, please remember it receives an input Vi here, okay, and the output of an amplifier is V0. Output of an amplifier is V0. This is an input, this is an output. So if there is no feedback, what will be the gain of this transistor, this amplifier? V0 by Vi is always called open loop gains. Is that correct? V0 by Vi is the open loop gain. Is that word clear to you? Because feedback has been taken away, then we say whatever is received at the, in this case what may happen, Vs may become ratio of Rs by Ri plus whatever into Vi, but Vi is the real input to a transistor and therefore the gain is Vs by Vo by Vi, okay, and that is called, without feedback whatever gain occurs we say it is open loop. In the feedback one can see from here I have taking a voltage across RL, okay, these 2 terminals are voltage, I am picking voltage across the output load RL and I am passing that voltage across a feedback network which has a gain factor of beta, okay. Since it is a voltage, it will give beta times V0 will be output somewhere here, beta times V0 will be output here, which I defined as Vf, beta times V0 is the sampled output. So the what kind of sampling I did here, this is my V0 and I am putting a shunt across the load, I am picking the voltage. So this is a shunt connection. What is series connection? Series to the, this will be series connection, across is shunt connection. So I am picking across outputs. So it is a shunt connection here, so it is called shunt sampled, is that correct? This has shunt sampling. This receives a voltage Vf which is beta times V0 and gives you a series voltage to the signal. Vf is equivalently saying there is a voltage source here as if here in series to the signal, is that correct? So how I am mixing? Series mixing I am doing, and since I am doing a series mixing and I am putting voltage plus voltage minus or plus sign correspondingly, then I say it is mixed series way at the input. Is that clear? So input is also voltage, output is also voltage, feedback is also voltage. Such amplifiers will be voltage amplifiers. Is that also called series shunt amplifiers? What are these called? Why it is called series shunt? The mixing is in series and sampling is at the output is shunt. So it is called series shunt amplifiers, okay. If I am looking for shunt series amplifier, then I do little trick. I say okay, the series connection at the output can only be taken if there is a current which can be input in series. Voltages, there is no voltage source except coming from the amplifier. So what we say, if there is a current amplifier whose output is I0 passing through RL, in normal case this will be connected, okay. So what will be actual voltage drop to you? I0 minus I0 RL, minus is because of the phase shifts. So V0 is still output if you need, is that clear? But what is real output for this amplifier? I0 is the real output of this amplifier. So I0 by II, if I use it, then I say it is current amplifier, okay. But the feedbacks we start looking, if this is my current and series to this, part of this current is fed back to a network which gives me beta times I0 as my feedback current. Now this current I connect it to a node, this node for example. Then I say if I had to connect it at a node, then I say it is a shunt. Any node, what is shunting? Across. At any node if you put a current, you say you are actually shunting at that point, is that correct? Shunt means what? Between two nodes. So I am adding a current and ground is the other side. So I am actually putting a current at a node, then I say it is getting into that. Okay. So this you can see the way I have fed. I have connected, which is the path for feedback current? It goes like this and comes like this. Is that correct? It goes like this and comes like this. Okay. So this is essentially, we say, shunting the current at the input. Remember what is being entered here? Current. This is a current source. I am entering a current here. That is getting modified by this current source, which is feedback current. Okay. That what is the II current will be here? Can you tell me now? If this is opposite phase, Is minus If will be the actual current II flowing inside the amplifier. Is that correct? If this current is leaving, this current is entering. So this current is Is minus If is whatever is going to the amplifier. So if If increases, what does that mean? That is feedback is larger. What does it means? II is smaller. If II is smaller, I0 is smaller. If I0 is smaller, If will become smaller next time. If If reduces, II increases. So I0 increases, and this will, in a loop kind, it will start reducing slowly and finally it will settle to a value in which I0 by II is the gain of the amplifier and fixed If will start flowing. Is that correct? This is the purpose of negative. Is that point clear? What is negative feedback? If it gets above, it reduces. If it is below, it pushes. Okay. Is that point clear? Why it stabilizes? If that current increases, then the feedback will reduce it, negative feedback. If it reduces, the feedback is lower and therefore input rises, so output rises. So it settles itself to a value which is essentially called shunt inputs, shunt currents here, and currents are series way picked up, okay, from the output. Such amplifiers are called shunt series amplifiers. By same logic we can do the other two. This is very interesting, both two. You can see from here, this is scratch part. I am taking a same sampling, current sampling, that is I0 amplifier. Output is what? What is output of this amplifier? Current, I0. Please remember, I kept on telling I0 into RL is going to give you V0 anyway. Is that point clear to you? So voltage can always be picked up by any current outputs. Okay. But this amplifier is essentially has I0 and II is the current flowing here. Okay. Voltage is the voltage across this amplifier is Vi. So what we are now saying that whatever is I0 is proportional to Vi by what factor? What is the gain here? Transconductance, current by voltage. So such an amplifier is a transconductor, output is current, input is voltage. So current by voltage is transconductance. Our input is voltage, output is current. So we have a transconductance amplifier and it is given by term GM. Okay. Though in our case we keep calling A everywhere, but as A can be GM, A can be RM, A can be current, AI, it can be AV. But in our definition of feedback we keep A constant. Okay. Is that point clear? How many A's can be? A can be AV, A can be AI, A can be GM, A can be RM. But essentially there are 4 separate amplifiers. Is that correct? Now in this case beta, this whatever is voltage across I am creating, so network is such that I put a series voltage in series to the source, then whatever this voltage is negative to this, correspondingly Vi will change and correspondingly I0 will change. Part of it feedback, again it is a negative feedback circuit. Input is at series, output is at series. Is that correct? Current is also in series and voltage is also in series. This is called series amplifier or also called transconductance amplifier. By same logic, both sides are shunts. This is voltage, this is current. Voltage divided by current is resistance. So these amplifiers are shunt which are essentially called trans resistance amplifiers, is that correct? So feedback allows you to create 4 possible amplifiers, okay. Now why are we want to do? Because many of the circuits which we have done earlier without knowingly that there was a feedback, you will see suddenly, for example, a source follower or an emitter follower, which will take an example later. Which kind of amplifier do you see it is? It is a voltage is being sampled and voltage is in series to the input itself. RE is common between the output and input. Part of the voltage is picked up across RE, it may be 1 here because the same is fed back, beta can be unity in that case. So whatever is received at the output is also a part of input, RE is common to both sides and series of that. So we say it is a voltage, I mean you can see it is a series at the input and what is at the output? Series. So we can similarly if I have a capacitance or a resistance between gate and the drain, is that correct? That will be a shunt because output is voltage but input is at that node. So we say it is a transconductance amplifier, trans resistance amplifier. So each name we may not have given there, but the amplifiers we have already seen them, is that correct? Whenever there is a connection between output and input by any impedance, whether it is resistance or capacitance or RC networks, these will form a feedback amplifier, is that correct? The nomenclatures we are now defining with the word feedback, bada naam deke, aisa nahi hai. We have already done those amplifiers, like for example the common source amplifier with source degeneration. The feedback is from where? From the load side, is that correct? So but the feedback is in from this side you are feeding it back. So one is current and one is voltage, okay. So now that we have already done those amplifiers, okay, but we have never named up which kind of amplifiers we are using because there we always say we are looking into voltage by voltage. All amplifier here also we can look as a voltage by voltage. After all, a current source is equivalent to a voltage source and a series resistance in Thevenin's way. A Norton source is equivalent to a Thevenin source. So essentially we are not actually trying to say we are doing something great. All that we are saying we are doing more generalized way of doing it and all other cases are more specific cases of that, okay. That is what you have to say, but the advantage what we get probably there we did not. Do you remember in common source amplifier with source degeneration or common emitter with emitter degeneration, what is the gain? The load divided by the degenerated resistance, typically all other factors are small. So RL by RE or RL by RS, that is what we said. What is the advantage we said there? The gain has reduced but it is independent of transistor stabilized. The word we did not say very specifically that time, stabilized, is that correct? Yes, feedback stabilizes the gain and gain reduced, is that correct? So please, why I am bringing this fact again just to tell you that we have already done most of the amplifiers in some way or the other. Many of them were feedback amplifier and that part we did not care because we solved a Kirchhoff equations, is that correct? If it is a feedback, so दोनों का दो equation लिख दिए. So we actually took care of feedback without actually telling it is a feedback. Whenever between drain and gate we connected, it was a feedback, output input was connected, or between collector and base we connected, we were connecting it, is that correct? So without telling you that this was a feedback amplifier, we solved as a Kirchhoff law without thinking because then I do not have to think anything. So what is this feedback theory is trying to tell? I need not do all that analysis for all of them. I can do something interesting. I can calculate the open loop gain and show how to get it. I can calculate A beta for that, okay, and then I directly can write A beta upon 1 plus A upon 1 plus A beta is feedback gain and I can find input impedance and output impedance, okay. That is something what I want to do quickly once I know that. But otherwise even if you do not know any feedback, we were anyway solving the circuit, is that correct? So do not think that this is trying to do something over and above that, it is only trying to generalize the same thing which we did earlier, okay. their individual case we solve, here you say you do not have to solve, you particular case is a specific case of this case, okay. So this is what I keep telling you, that the books do not want to tell this, they have a separate chapter telling as if this is an individual extraordinary work we are doing, no it is not actually. Another thing which feedback provides us is something called, a word which we call non-linear distortions. कोई आप मुझे बता सकते हैं कि नॉन लीनियर डिस्टॉर्शन का मीनिंग क्या होता है, या फर्स्ट लेट्स फॉरगेट डिस्टॉर्शन वर्ड, लीनियर एंड नॉन लीनियर क्या टर्म होगी. इफ आई हैव ए फंक्शन एफ एक्स एंड इफ इट इज लीनियर it may have a coefficient a0, okay, it's a linear system. But if I have a term, it has become non-linear, is that correct? Higher terms to or be, that is non-linearity will keep on increasing, okay, as we get cube term, fourth term, fifth term. But if x is your signal, sinusoid signal, let us say Vi is a sin omega t. So what is Vi square? A square sin square omega t. Sin square omega t को कुछ और expand कर सकते हैं क्या? Sin 2 omega t is how much? 1 minus 2 sin square omega t 2 omega t. Is that correct? Sorry, it is either way. Okay. So what does that mean? Square terms will be give what terms to us? The omega t terms is coming from the first one, but 2 omega t terms will coming from the square terms, okay, and higher order terms will give higher order frequency. So these are called harmonics, okay. Omega is called fundamentals, any number proportion to this omega, 2 omega, 3 omega, these are called harmonic. But whenever harmonics are present, output will also show you corresponding those frequency outputs. V0 will also have a components of 2 omega t, 3 omega t apart from omega t, omega. What does that mean? In real life, I will see to it that I receive power only at omega, my fundamental. I may do some what we call tuned circuit there, so which will pick up only signal at omega. But what is it means then? That the power which has or energy which has gone to 2 omega, 3 omega or n omega, I have lost. So the efficiency of an amplifier will keep reducing as non-linearity starts increasing, is that correct? Because you will actually not get equivalent voltage if you would have got a linearity, some part of it is as if is lost by you, is that correct? So if you see, this is what theory I was telling, and you can now see very easy. See, there is a V0 Vn characteristics from some value say here to here 40 to 40 volt millivolt, it is linear, output is minus 5 to plus 5, okay. Yeah, it is not necessarily, this is from op-amp, so one typical values I chose from an op-amp. Okay. So we say, let us say this linearity has a gain of 100, okay. Any gain can be assumed just for the heck of it. So if Vin is less than 40 millivolt or greater, actually minus 40, from here to here one can see that output will be proportional to Vn, 100 times Vn, is that correct? But if you look for little term which is ahead of this, where non-linearity has started, it is not, maybe that does not, cube terms are smaller there, that is A3, A2 coefficients are smaller, but at least square terms will appear, because it is not linear, so second term to aa gaya aapke paas. So if we say V0 is 100 within this range plus minus, and the second term will now V0, at least अभी एक तरफ का देखो स्क्वायर में तो कोई फर्क नहीं पड़ेगा, V in minus 0.04 square, and as I just now said, when I square the inputs, I will see in outputs also 2 omega 3 equivalent terms now. So we say from 40 volt to 60 millivolt, we may say only second harmonic appears, that is the dominant other frequency than omega is 2 omega. But if we go beyond 60 millivolt, the gain is really becoming flatter now, which means there will be more cube and maybe 4th order, 5th order terms will also start appearing, that means gain will start reducing drastically. So beyond this we may say voltage become fixed to 5 volt maximum. Does that occur in op amp? If op amp has a power supply of minus 5 plus 5, it saturates at plus 5 or it saturates at minus 5. So I that's what I said, that typically op amp characteristics I chose to explain my term. So I want to see that if there is a non-linearity, how much non-linearity is tolerable to you. So we want to see, since our swing is now 40 millivolt only, minus 40 plus 40, but I have a signal which is 100 millivolt, then what will happen, where the output will go, fixed 5 volt, nothing else can be done now, okay. But I want actually linearity there, okay. So one method of improving the linearity of a non-linear system is to give a negative feedback, is that correct? So what is the advantage of negative feedback will be seen, that if I give a negative feedback, but at what cost I will get it, lower gain. अभी कितना gain है 100, okay. If I do, if this is my normal amplifier 100 वाला, okay, ये वाला 5 वोल्ट से माइनस 5, यदि मैं वैल्यूज तुमको फिर दिखा रहा हूँ, यदि मैंने फीडबैक दिया तो मैं अराउंड, यदि फीडबैक गेन 10 भी है तो 450 मिलीवोल्ट टू 450 मिलीवोल्ट तक मैं इसको लीनियराइज कर दूंगा, पर गेन कितना किया मैंने 1/10, 100 का 10 कर दिया मैंने. सो फीडबैक लगाने से I have reduced the gain 10 times, okay, but what did I achieve? The input signal range has now increased by 10 times, okay, 450 or 400 millivolt to 4. So large signal amplification यदि करना है तो क्या करना पड़ेगा, feedback amplifiers use करना पड़ेंगे. So do you know, now I have reduced nonlinear distortion in this. Why do I say I have reduced now? Because now up to even 450 millivolts or minus 450 millivolt, there is no nonlinearity. And if there is no nonlinearity in that range, then we say there is no distortion in that range. Is that clear? If the gain linearity is up to higher values of signal, there is no nonlinearity. So by actually providing you a feedback, what did I achieve? Linearity was improved by me by order, because the gain I reduced by an order. Is that correct? So this is another advantage I see whenever I have a large signal amplification desired. What does that mean? Where does this large signal amplification will be required? First stage of a normal amplifier may not be a feedback amplifier. आपने पहले 5 मिलीवोल्ट और 100 का गेन है तो 500 मिलीवोल्ट आउटपुट आ जाएगा, है ना, तो आप इनपुट और भी कम करना पड़ेगा आपको. पर नेक्स्ट समझो आपका 400 मिलीवोल्ट आउटपुट आया है फर्स्ट स्टेज से, तो नेक्स्ट स्टेज को तो फिर वो करने ही नहीं देगा क्योंकि वो तो सैचुरेशन में पहले पहुंचा देगा. बट आई वांट टू एम्पलीफाई स्टिल दिस सिग्नल व्हिच इज हायर वोल्टेजेस. सो व्हाट शुड आई डू देन? I put a feedback for the second stage, reduce the gain but still boost that. Is that correct? By increasing my linearity range to higher input range, I have now been able to actually have a two-stage amplifier with a larger outputs available for inputs which are larger now, okay. This is the advantage of having nonlinear distortion reductions. Is that correct? Yes. Saturation is the ultimate, it may be 100 polynomials non-linearity or 1000 polynomials, is that correct? But even at the when the linearity starts bending down and signal output start bending, there is a non-linearity term has appeared, and that means the first order term के साथ second order terms आ गई, और थोड़ा bend हुआ तो third भी आ रहे होंगे. So at the edge also, if you have a normal amplifier, ठीक है, ये 40 के बजाय 45 तक नहीं देगा, उससे क्या फर्क पड़ा, मुझे तो 500 चाहिए था. Oh, this is just to give an example, young man. Wherever it will start bending, and if why so you say why feedback 10? I am only trying to say you that by increasing the, if I want increase input range, I can actually put a feedback to reduce the gain and then increase the linearity. This is the purpose. That means at least in this range linearity is maintained by me, therefore non-linear distortion does not occur in this range. In this case even here itself I have a non-linearity starts, okay. So my input swing is very low. So if my input swings are higher, then what do I do? And I want linearity. Normally in what we call tuned amplifiers, which are different kinds, we are just now looking for amplifiers called class A. But if we are looking for amplifiers like class C or class D or class E, class F, we are not interested in linearity anyway there. Is that clear? Since we are not talked, please remember there are class A, class B, class C, class D, class E, class F. 6 kinds of class of amplifier also exist. All class A amplifiers are essentially linear amplifiers. Is that correct? Output is directly proportional to inputs. So all the amplifiers so far we are talking is class A. All that we said, if I want in a class A amplification in which I do not want distortion, I can put a feedback. Is that correct? But not every amplifier need be work. There is also another in between called class AB. Okay. So I think maybe at the end of the day I may show you quickly what are these classes and where do they use. All radars for example will be using either the class C if it is sinusoid, if it is a pulse transforms then you will have class D, class E or class F amplifiers, like all mobile systems, mobile transmissions which is running at 890 megahertz to above, or Bluetooth running at 2 to 4 gigahertz, there we are using class F, class E amplifiers. Is that clear? But there we are not worried about, we are actually using non-linearity. Is that correct? So it is not my contention that non-linearity is always bad. Is that point clear to you? What I am saying, in a class A amplifier, if I have to improve the input range for distortion free input range, then I must put feedback. Is that point clear? Okay. So having told you this, let us do something more. Okay. So here is something which I will like you to, so this is a graph which is called signal flow graph. Okay, this is only shown for this circuit but can be shown for any circuit. Okay. What is said, this is my amplifier. Okay. This is my signal in Vs, input to A0, the output of this is some Vin, and from Vin to input of signal we will say why it is Vin dash a hat. Okay. Then there is the amplifier A0, and then this another term we say, let us say all distortions are taken care as a noise at the output. Okay. All distorted outputs are taken as an equivalent of a Vd noise at that point. So we say whatever is coming from amplifier will be added by this Vd. Is that correct? But if you have a feedback here, directly it will come as a Vd. But if you have a feedback like this, one can say V0 is not only AF Vs but plus Vd times divided by 1 plus A0 beta. You can do this analysis as we did earlier. Okay. So what does this essentially means? Now the noise factor is actually reduced by 1 plus T factor. Is that correct? Gain of course has also reduced. Doing so, earlier it would have been A, now it is AF. But by doing that I have actually seen that the distortion outputs or noise outputs also get reduced by 1 plus A beta times. So one can say this term being very very small, output is proportional to input. That is what the graph I was trying to show you. Looking at the Vs to Vin, there is no any network. Why this one has been put here? Because there is a direct transmission here. Okay. But if there is a Rs or some combination, this itself will have some gain there, less than 1, but Rs upon something by this. So this यहाँ से यहाँ आने तक अभी तो gain 1 है, तो उसको gain लिखते 1. Okay. We also right now don't tell you, but why I want hats I will come back when I draw feedback full amplifiers. From Vin to Vin hat there is no change, it is same connection. So we say it has also a gain of 1. Vin hat goes through an amplification of A to get to a V0, At this point we have a distortion through a sigma, and we say all of it is connected at the output. If there is a network here also, it may further reduce like in feedbacks. So here is V distortion, and all of this through a gain of beta is fed back to Vn. Is that correct? ये देखो यहाँ से Vs से Vin आया, Vin से Vin hat आया, Vin hat से V0 का पहला वाला आया, यहाँ पर ही Vd भी मिला, और ये यहाँ से आउटपुट through a gain of beta is returned to this Vin, this point. Whatever I am showing here, this has a gain of 1, this has a gain of 1, this has a gain of beta times whatever it is. Okay. So we say whatever amplifier we say, we can represent that circuit by a signal flow graph. Is that correct? इसका arrow कैसा होगा? अच्छा, ये another thing, there is a arrow you have to show everywhere. What does that arrow means? Signal path going from where to where. From this node to this node, signal is going in this direction. So this node to this node, signal has gone from this direction. Okay. From here it has gone to Vn hat with a gain of 1. So it has gone to this node, which is Vn hat node, by gain of 1. So here also I must have an arrow. From Vn hat there is an amplifier to go to V0. So I have gone to V0, which has a gain of A. At the same point I have a distortion input with a gain, assuming here से यहाँ आने में 1 ही है, same input वहाँ आ रहा है. So it is this point, and from here I am feeding back beta gain के साथ. So any amplifier circuit can be represented by signal flow graph. Is that correct? So बहुत बार आपको क्या है, एग्जाम जब प्रॉब्लम, नॉट एग्जाम बट they may not show you all that. They say okay, this is the signal flow graph for the system, design and this for it. Okay, but essentially it is this system. Please remember, there is nothing great in signal flow graph. Okay, all that it does, it's larger such a blocks of circuits can be represented by only lines, and they can also represent the function going through. These are called signal flow graphs. Is that correct? Now why are we interested in signal flow graph? इतना trivial भी नहीं है ना, सिर्फ दिखाने के लिए नहीं किया हुआ ना. तो word लगाया हमने graph, तब आप you will know it. Since I have a graph, I can manipulate it better than anything. Okay, and then my solutions will be faster, and then only I have to solve smaller parts. Okay, so signal flow graph do help us at the end to give a smaller circuit solutions. Okay, therefore signal flow graph theory is relevant. Okay, the most important thing in a feedback amplifier is feedback gain, but that's smaller value. We already said A by AB, 1 plus A beta, gain reduce हो जाता है. But doing this, do we achieve something else or do we lose something else? I call it achieve or call it lose. So we say okay, the other two parameters of interest in an amplifier, one is gain, of course also a bandwidth. Right now please remember, I am not talking of bandwidth part. This will do separately. What bandwidth, we did say that bandwidth increases, okay, but we will actually see Bode's plots of feedbacks and how do they change. Okay, but as said, right now we are not talking of bandwidth. So what two other parameters of an amplifier of interest to us is the input resistance and the output resistance. So we said start looking into it, because of feedback, does it happen differently then? So we figured out, yes, feedback has also influences on the Ri and Ro both sides, R out both sides. So we see what are in 4 cases which we had, one series mixing, shunt mixing, series sampling, shunt sampling. So all चारों केस में Ri Ro क्या होंगे, we will like to see. Okay, so we said okay, let's look at, this is the normal amplifier. Okay, for the simplicity right now I may neglect Rs. We can always add this Vs can be modified by something into this and use a new source, Thevenin source. So right now we say Vs is the source and this is beta times V0. This is series mixing. What thing I am talking about? series mixing, voltage is in series to the signal, and the input impedance resistance is seen before the feedback, that is after the source, after this is Ri will be seen. Please remember Rs is not part of Ri, is that correct? Rs is not part of Ri. So whatever voltage actually I am looking at here is I am calling Vs, is that correct? Though it may be ratio of something, but essentially I am saying because I am only interested here, okay. So this is my source, this is my feedback which is reducing Vs because it is a negative feedback, and I want to know what is the input resistance here. Without this feedback, how much is our input resistance? Ri, there is nothing else. If I put a voltage source there, V bias, there is nothing to see about, there is only one resistor sitting here. If I see it, only I see that, nothing else I see, okay, is that correct? But something else I may see, this Ri may include the bias resistor network or any other thing which you say may include in this Ri, but for me it is only Ri, is that correct? So I am seeing here Rn is only Ri, okay. But if I have feedback, then I want to know, I say AF which is the gain, which is V0 by Vs, AL by A beta, which is this is our feedback gain for an amplifier. We say Ri is Vs hat, that is the voltage at this point, okay, divided by Ii, which is my, in the first case this is Vs hat I put it, so it is Ri. With the new one I find Rif is Vs divided by current, is that correct? What is the resistance seen here? Voltage divided by current. देखो फिर से, ये voltage है यहाँ पर, ये current है, is that correct? So Vs divided by Ii is the resistance seen by the source into the circuit, is that correct? But now I see this Ii current, it is not same as, it is now getting as if modified by feedback. If that is not there, Ii will be same as the old current, okay. But if there is a feedback, I now see Ii is nothing but Vi divided by Ri, is that clear? Vi divided by Ri. But this I know Ri, Vs divided by Vi, Vs divided by Vi. Now we say Vs, you can see here, Vi plus Vf is Vs, this voltage drop plus this voltage drop is this, Vs is this voltage plus this voltage, is that correct? So Vi plus Vf is Vs, which is essentially Vi, and what is Vf? Beta times V0, but what is V0? A beta times Vi, अभी दिखा है ना ऊपर से, A beta times Vi. So we say Vs is nothing but 1 plus A beta times Vi, substitute here, so I get Rif, which is the feedback input resistance, as Ri times 1 plus A beta or 1 plus T. So क्या बढ़ा के कम हुआ? बढ़ गया है ना. So यदि सीरीज मिक्सिंग है तो इनपुट रेजिस्टेंस बढ़ जाता है, नेगेटिव फीडबैक. कंसेप्चुअली क्या बोल सकते हैं क्यों बढ़ा? व्हाट इज द करंट इन द सर्किट डिसाइडेड बाय the voltage divided by resistance is the current. In the feedback the voltage reduces, that is why negative feedback means voltage reduces across this. If it reduces, the current also reduces. Resistance में क्या होता है, करंट कम हो गया तो क्या होता है, रेजिस्टेंस बढ़ जाता है. Vs तो फिक्स रखा है ना आपने. So what essentially feedback is doing, it is reducing the current in the input mesh, is that correct? And because of that the input resistance is that physical word clear? Because that reduces, current reduces, that means the net resistance increases, and the feedback essentially is telling the input resistance of a series connected at the input mixing will always be higher than. कौन से सर्किट में हमने ये आ रहा है ज़्यादा देखा था? किसी भी एमिटर सर्किट में यदि रेजिस्टेंस है ओके तो इनपुट में कितना दिखेगा यदि बाइपोलर ट्रांजिस्टर है तो beta times Ri will be reflected inside, is that correct? Beta times Ri will be reflected, so R pi plus beta times Ri will be the actual input seen by the transistor, is that clear? What does that mean? Input resistance increases whenever Re is present unbypassed. Common source or common emitter amplifier with source degeneration or emitter also will increase Ri, is that correct? Will also increase Ri. So whenever there is a series mixing where the input voltage is modified by another feedback voltage, the resistance at the input will always increase. So ये कहाँ जरूरी पड़ सकता है? Where do you need your input resistance be higher? Generally amplifiers have smaller R0s, is that correct? Now if I have a smaller R0 and I am feeding it to a next stage which also has equivalent resistance there. So what does that mean in terms of maths? If I am having a circuit whose R out of 1 is lower and I have a next stage whose RO2 in, if these are comparable, part of the current is going here, part will go here. Okay, what is it called? Essentially the net resistance will actually reduce and therefore the voltage at the input will not remain voltage which you were feeding, is that correct? So what should be ideally, RO2 should be much greater than RO1, then what will happen? All the current is only here, so this voltage remains constant, so the next stage sees same output of its first stage, otherwise it will get modified. And what does that word in other circuit be called? Loading. The next stage starts loading the first stage, is that correct? So अभी लगा क्या तो फर्स्ट स्टेज एम्पलीफायर के बाद बहुत बार क्या लगाना पड़ता है नेक्स्ट स्टेज बफर, बफर यानी आर ई अनबाईपास और आर एस अनबाईपास. सो उसका इनपुट इम्पिडेंस बीटा टाइम्स या गेन टाइम्स इनपुट में आएगा. So it will be larger there. So any source now coming from there will not get modified for the next stage. Is that point clear? That is why buffers are required. Is that correct? What is the advantage of buffer other than the input resistance match? Its output is still low. Okay. So if you have a circuit which requires load next, which is low this, you have a RO lower, at the same time you are matching with the first stage. Is that correct? That is why it is impedance transformer, as we can say, higher impedance connected to a lower impedance. Is that correct? And what is the gain of a such stage? Normally buffers, unity gains, because a common source follower or emitter followers. Okay, is that clear to you? Always a emitter follower or source follower is kept whenever impedance need to be matched between two individual stages. बीच में एक buffer डाल दो. Okay, is that clear? So this is the technique we use everywhere. So this is why we say we want to reduce this effect of loading, we need to know some kind of impedance modifications. Is that correct? In some circuit you may require RO reduction or RO increase. We can do all four. We can increase RI, decrease RI, increase RO, decrease RO. They are all possible. Oh, there is no hat. The hat was done here because you would have asked, is it Vs here? This Vs, okay, call it hat here. Okay. No, actually we are not. What we are trying to say, whenever I calculate input impedance, I don't consider real source and its series resistance. Is that correct? So वहाँ फिर भी जो equivalent voltage आता है वही हम Vs hat बोल रहे हैं. Is that clear? I am not saying RS is 0 because that is something tomorrow will say sir आपने बोला था हमेशा RS 0 होता है. RS कोई 0 नहीं होता है. Source, any signal source you put, there is a series. I cannot avoid it. Any voltage source will have a series resistance. Is that clear? Low होगा 50 ohm हो सकता है, but होगा जरूर. Okay. The lowest is 50 ohms. Okay. 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 If I do shunt mixing at the input, please remember shunt. What kind of mixing can be done by shunt? Not by voltage. Voltage cannot be shunt across. एक voltage source के across दूसरा voltage source दूसरा नहीं लगा सकते ना. तो क्या shunt कर सकते हैं? Current sources. So this is my current source IS and this is the feedback IF and I am putting an RIF here, okay, and I want to know what is the RIF. Now I know IF is beta times x. Why I said x0 generally? Because I am now saying either at the output sampling can be voltage or sampling can be current, but that the input it is always shunt. Is that word clear to you? Input is always shunt, but output is always can be voltage or series or shunt, either case. So मैंने दोनों को एक में मिला दिया. So is that point clear? It can be V0 or I0, either of them can be X0, but I have made a generalized this, okay. Because it doesn't matter, X0 ऐसे भी निकल जाएगा उसमें से, इसलिए it doesn't matter whether sampling was shunt or what we are looking essentially input side. आपको इनपुट में मिक्स क्या होता है वही इंपॉर्टेंट है, पर गेन के लिए आपको कुछ नंबर पता होना चाहिए, ओके. सो X0 is A times II. Now as I say, it can be either of kinds, okay. What is II current? Is minus If is II, which is entering Ri, Is minus beta X0, Is minus A beta II, 1 plus A beta II is Is. So Rif is Ri upon 1 plus A beta. Whenever I want to find an impedance, input impedance, what do I do in real life? I short all outputs, is that correct? I remove all independent sources other than the for which I am finding. That is the case I was solving. Is that clear to you? तो मैं as if Vx वहाँ लगा रहा हूँ और Ix ढूंढ रहा हूँ. किसी भी नेटवर्क का यदि इनपुट देखना है तो मैं एक वोल्टेज सोर्स लगाया, एक करंट उसमें से निकला Vx by X. So that is what all that I am doing. Is that point clear? So वो RS है कि नहीं ये नहीं है, जहाँ मैं देख रहा हूँ वहाँ मैं अपना सोर्स लगाऊंगा, बाकी सब छोड़ दूंगा. Is that clear? So what is the disadvantage from this system or advantage? इसमें RIF कम हुआ या ज़्यादा हुआ? कम हो गया. क्यों हुआ? अब currents का उल्टा हो गया actually. Is that clear? Because current is a feedback. The net current II essentially is reducing. II is sign wise if you see. That means V by II upon 1 plus beta, that means ये जो फैक्टर है वो रेजिस्टेंस को उतने रेशियो से कम करता है. पहले इसमें क्या किया, बढ़ा दिया, दूसरे में क्या किया, कम कर दिया. ऐसा ही हम आउटपुट पे कर सकते हैं क्या? उस समय क्या करेंगे, इनपुट को लगा देंगे शॉर्ट, ओके, और आउटपुट से देखना शुरू कर देंगे, उसमें लोड्स हटा देंगे. इज दैट क्लियर? लोड्स आर नेवर कंसिडर्ड इन कैलकुलेटिंग output resistance. So here is one more case I will solve and we will stop on this. I want to find shunt sampling. Let us say AXI is the gain. Again what is XI? XI क्या होगा, ये इनपुट है, वो क्या हो सकता है, वोल्टेज हो सकता है या करंट हो सकता है, तो दोनों को जनरलाइज कर दिया मैंने, ओके. AXI is the voltage which is appearing, AXI is anything, मैं प्लस माइनस अभी वोल्टेज इक्विवेलेंट सोर्स दिखा दिया, उसका सीरीज रेजिस्टेंस जो इस वोल्टेज सोर्स का है वो है R0, and this I now apply a Vx Ix. Vx is the source I applied the output and measure the current Ix. With feedback Xi will be 0, input will be shorted. Is that correct? For output resistance input कितना होगा, 0. So Xi तो 0 कर दिया. Xi 0 किया है ना, वोल्टेज 0 किया कि करंट 0 किया? नो बिकॉज एक्सेस वो वहीं पर है ना, वो शॉर्ट है उसके अक्रॉस. सो यदि उसको शॉर्ट करते हैं तो वॉट एवर रेजिस्टेंस सीन हियर इज सेम एज आर ओ, ओके. सो विदाउट फीडबैक द आउटपुट रेजिस्टेंस इज द आर ओ ऑफ द सोर्स, आर ओ ऑफ द सोर्स, ओके. बट यदि फीडबैक है जैसा कि यहाँ है, अभी देखिए आर ओ एफ इज वी एक्स बाई आई एक्स, एक्सेस इज एक्स आई प्लस एक्स एफ. X can be current or voltage whatever it is, with XS equal to 0, you said it now, XS equal to 0, Xi minus is XF, which means beta V0. So Xi is minus beta Vx because V0 is same as Vx. So Xi is minus beta Vx. Substitute. What did I do? दिस इज ए शंट सैम्पलिंग गोइंग ऑन, इज दैट करेक्ट. सो करंट वोल्टेज को सैंपल किया गया यहाँ पर, इज दैट करेक्ट. I applied a Vx source and I want to see what is the current coming out to get my resistance Vx by Ix. So I said at the input side I shunted the source, shorted the source, not shunted, short. So Xs is Xi plus Xf, Xs को मैंने 0 किया तो Xf is minus Xi, isn't it? But what is Xf? Beta times V0. कितना फीडबैक मिला? बीटा टाइम्स V0, ये वोल्टेज सैंपल है ना. सो बीटा टाइम्स V0 इज द वोल्टेज सैंपल एट द इनपुट एज ए फीडबैक. सो Xi is minus B and V0 is how much? Vx. So Xi is minus beta Vx. Is that point clear? फिर से देखो, this is voltage which is same as Vx. Sampling is beta times V0 because it's a shunt sampled. Feedback is वोल्टेज नाउ बीटा V0. इक्वेशंस में इनपुट साइड में देखेंगे तो सोर्स प्लस इज इक्वल टू Xi इन एट द इनपुट ऑफ द एम्पलीफायर प्लस द फीडबैक, इज दैट करेक्ट. अभी आपने एक्सप्रेशन देखे ना पहले, इफ Xs इज 0 द फीडबैक इज अपोजिट ऑफ Xi but Xf is beta V0, so Xi is minus beta V0 or beta Vx. Xi is the input to the source. This amplifier में ये जो यहाँ पर जो भी इनपुट आता है उसको Xi बोलते हैं, is that correct? Xs is here. So Xs में क्या, ये वोल्टेज प्लस फीडबैक, ये मिलके Xs है ना, ये वोल्टेज प्लस ये वोल्टेज is this voltage. Is that clear? So that is the word which I have used there. Okay. So what is Xi? Minus beta Vx. So if I now say Ix, which is the current flowing here, is Vx plus A beta Vx by R0, which is my current now. इस सादे सर्किट से करंट निकालो. Ix is equal to Vx plus drop A beta Vx coming from here. Xi अभी है ना, अभी what is Xi? Beta Vx अभी निकाला ना, उसको सब ऐड करो सोर्सेस को. Vx plus A beta Vx divided by R0 is the current. Is that point clear? This voltage plus this voltage, यहाँ Vx है, इसके plus ये है, divided by this current is the by this resistance is the current. Is that correct? So Vx plus A beta Vx upon R0 is the Ix. So Vx by Ix is Ro upon 1 plus A beta. So it is ROF is 1 Ro by 1 plus T. तो Ro बढ़ा के कम हुआ, शंट सैंपल में कम हो गया. सो यदि Ro को रिड्यूस करना चाहते हैं तो कौन सा सैंपलिंग होना चाहिए? शंट सैंपलिंग होना चाहिए. We didn't do it for the opposite case, second last case. I have a series sampling. सीरीज में क्या सैंपल होता है? करंट सैंपल होता है. By similar logic, if you solve that, you will get ROF is equal to how much? 1 plus A beta times R0. So the feedback output resistance is higher than the resistance with output resistance without feedback if you have a current sampling going on. Is that correct? So now you have 4 cases: series mixing, shunt mixing, series sampling, shunt sampling. So now could you get, I can get both lower, one higher, one lower, first lower, next higher or both higher by a proper choice of mixing. Is that point clear? I repeat, since I have 4 amplifiers, I can increase Ri and increase Ro simultaneously. I can increase Ri but decrease Ro. I can decrease Ri, increase Ro, and I can increase both Ro and Ri. All 4 possibilities, 4 amplifiers will give me. So whatever requirement I have in my actual requirement, I can choose one of the feedback blocks of that kind and I will use them in between to create the Ri and Ros of my choice. Is that clear? This is the advantage of feedback, that at what cost all that I am doing every time? The gain को छोड़ा है मैंने. हाँ, तो एक बात सर्किट का है या नेचर का भी है या अपना ह्यूमन का भी है ना. लीनियर सिस्टम, मेरा तो लीनियर सिस्टम में पहले बता दिया. The output grade is essentially proportional to your input work. Okay, do whatever you say. Okay. Thank you very much.